Good morning. I hope everyone's excited and strapped in. I have the great pleasure of inviting everyone in for science-related projects, experiments that will be hosted by our corporate partners, which include DuPont, Boeing, FMC, ILC Dover, and Elite Universal Network.
Hi, my name is Don Klopp, and I work for ILC Dover. ILC Dover is a Delaware corporation. We have our principal location where we do most of our design engineering and manufacturing in Frederica, Delaware, which is just south of Dover, Delaware. But we also have manufacturing facilities in Ireland, Switzerland, and Mexico. We have a lot of product lines in ILC Dover. Our biggest product line is our pharmaceutical containment systems. These are systems used in pharmaceutical manufacturing to contain the active pharmaceutical ingredients, which many of those are in powder form, and they can very fine powders that can float through the air and cause damage to the workers in those manufacturing facilities. So we make systems that contain those and keep the workers in those manufacturing facilities safe. Another product line we have is personal protective equipment. This is equipment to protect workers in the case of respiratory threats. So for instance, with the current coronavirus, a lot of healthcare workers use our personal protective equipment so they protect themselves from the respiratory threats that may be in the air as they're working with patients. We also have a product line in intermediate bulk packaging. We make bulk packaging products. We also do flood barriers, flood protection systems. We have another product line where we make blimps and aerostats, like the Goodyear blimp that you might see above a sporting event. We made that here in this facility here in Frederica, Delaware. And the product line that we're maybe most famous for are our spacesuits. Standing in front of a couple of spacesuits here. We designed and manufactured the suits used for the Apollo moon landings back in the late 1960s and early 1970s. And we've made every EVA suit for NASA since then. So we've been the exclusive spacesuit provider to NASA for over 55 years. This is an Apollo era spacesuit. This was the outer layer, except for the upper arms here, is not on this suit. So the suit normally would have a white outer layer. Spacesuits are always white to reflect as much solar energy as possible, but this doesn't have the helmet on and it doesn't have most of the outer layer on. This is a modern spacesuit. This is a spacesuit that NASA calls the EMU, the Extravehicular Mobility Unit. So this is a suit that the astronauts wear when they take spacewalks from the International Space Station. Maybe I'll tell you a little bit about what goes into the design and manufacturing of a spacesuit and what it needs to do to keep the astronaut alive during a spacewalk. So there's sort of 5 things that we kind of take for granted here on Earth that keep us alive as human beings. One is air pressure. So here in Delaware, we're pretty close to sea level, and the air pressure here is something around 14.7 pounds per square inch. So right now, pressing against your skin, on all sides of your skin, is 14.7 pounds per square inch of air pressure. If you don't have that air pressure pressing against you, bad things can happen to you, because we were evolved on this planet to adapt to this environment. Another thing that we need is a component of the air that provides that pressure needs to be oxygen. We need to breathe in oxygen to keep us alive. Another thing the suit has to do is provide thermal protection, has to provide radiation protection, and micrometeoroid protection. So let me talk about each one of those maybe a little more depth. As I said, we have about 14.7 pounds per square inch of pressure here at sea level on Earth. Out in orbit on the outside of the International Space Station, the air pressure is essentially zero. It's a little bit above zero, but it's such a tiny amount above zero, it may as well be zero. And a human, in order to stay alive, needs at least 3 to 4 pounds per square inch of pressure pressing against your skin. So when you go up to the top of very tall mountains on the Earth, say the top of Mount Everest, the air pressure drops considerably, but there's still enough there to keep a human being alive. But as I say, up in space, when you're orbiting the Earth, outside of the Earth's atmosphere, there's none of that air pressure, so you need pressure against you. So the suit is a pressure garment. It contains air pressure and maintains air pressure inside the suit. As I said, you need oxygen to breathe. As human beings, we breathe in oxygen and we exhale carbon dioxide. So we need to continually refresh that oxygen in the suit. And there are, in the life support backpack back here, there is an oxygen supply as well as a system that scrubs the excess carbon dioxide out. So as you're breathing out and the air is getting circulated through the suit, it gets circulated through a device in the life support backpack that takes the carbon dioxide out of the air that's inside the suit. Another thing that's required is we need to stay in a certain temperature range to stay alive. So here on Earth, the coldest temperatures that you might see, say at the South Pole, are minus 70, minus 80 degrees Fahrenheit, maybe a little bit colder in certain cases. But out in space, on the shadowed side of the Earth, the dark side of the Earth, so as you're orbiting the Earth, you go from being on the side of the Earth that's facing the sun, if the sun is over here, to the side of the Earth that's not facing the sun. So it's in darkness. On the dark side of the Earth, in low Earth orbit, the orbit that the International Space Station traverses, the temperature on the dark side of the Earth is about minus 250 degrees Fahrenheit. That's 250 degrees below zero. Very, very cold. But as you come to the warm side of the sunny side of the Earth, the side that's facing the sun, the temperature goes up dramatically in orbit without the atmosphere to sort of buffer the effects of that thermal energy coming from the sun. The temperature goes up to plus 250 degrees Fahrenheit. So easily warm enough to boil, more than enough to boil water. So the spacesuit has to provide thermal protection for the astronauts and has to adjust between the cold side and the light side of the Earth. So in low Earth orbit, the orbit that the International Space Station traverses, it takes about 90 minutes to do an orbit of the Earth. But a typical spacewalk today usually lasts between 6, 7, maybe as much as 8 hours. So during that, say, 7 hours nominal that they're on a spacewalk, they traverse every 45 minutes. They're on the light side, and then they spend 45 minutes on the dark side, and then another 45 minutes on the light side. So they are through 7 or 8 cycles of going from hot to cold or cold to hot during a single spacewalk. So the spacesuit has to protect the astronaut from being too hot on the light side of the Earth and too cold on the dark side of the Earth. So that's an important function of the spacesuit. The spacesuit also has to provide radiation protection. So our atmosphere here, when we're on the surface of the Earth, does a pretty good job of filtering out most harmful radiation. We get a little bit of ultraviolet in the ultraviolet B range, what's called UVB, that can be damaging to your skin. Long-term exposure to that can cause potential problems. But when you're outside of the Earth's atmosphere in orbit, so there's no atmosphere above you to protect you, something else needs to protect you, and that's where the spacesuit comes in. Because there's forms of ultraviolet radiation in the UVC range that we don't even see here on Earth because our atmosphere filters out all of it, as well as what's called vacuum ultraviolet, VUV light. which is very damaging to your skin, and much shorter exposures can cause problems. So the spacesuit is designed to keep all of that out. And as far as the helmet bubble, when the astronauts are on the dark side of the Earth, what's not shown in this are we have helmet-mounted lights. So there's a pair of lights that shine on what they're working on, so they can see when they're on the dark side of the Earth. But when they come to the light side of the Earth, they have to flip down this sun shield to protect their eyes. And depending on where they're working, they may also need to flip down. Oops. These are side shields. This one is a sort of a visor. So depending on where they're working on and where their line of sight is on the International Space Station, they may need to flip down various visors to protect against the very bright direct sunlight in orbit. And the final thing a suit needs to protect against is micrometeoroids. So these are tiny pieces of, I think of them as space dust, but they're flying at incredibly high velocities. And if you didn't have a spacesuit on, any protection on, these things are flying so fast that they would penetrate your skin, just like a bullet. So the outer layer of the spacesuit is actually a material that's very similar to Kevlar, the material that we make bulletproof vests from. So it protects from penetration of those tiny pieces of space dust if they were to hit an astronaut during one of his spacewalks. Another thing that I'd like to talk about, maybe just in closing, is how we make different sizes of suits for different size astronauts. Some astronauts are bigger. I'm a pretty big person myself, so I'd need a suit that was pretty large if I were to go into space. But then there are also much smaller people that take spacewalks. In the Apollo era, when we made these suits back in the 1960s and 1970s, these were custom tailored for each astronaut. So Neil Armstrong and Buzz Aldrin, the first two people to walk on the moon, they actually came here to our factory, right where I'm standing now, and got sized for a custom-sized suit. So each astronaut had their own suit. Today, with the International Space Station and a lot more astronauts taking spacewalks, we don't do that anymore. We build suits in a very modular fashion, so they're made in components, and we assemble the components then to fit a specific astronaut. So for instance, here is a boot section. So we make these in several different sizes, and this just then attaches to the spacesuit. Here is an upper arm section. So this is actually quite large. This would probably fit me. And this, but we make different arm sizes, and this just clips onto what we call a shoulder bearing, and then there are different size upper torsos as well. We make a small, a medium, and a large upper torso, and then a variety of size arms, a variety of size gloves, and I'll talk about the gloves in just a second, as well as a variety of size length legs and size boots. Another thing that the astronauts have to do is they have to communicate with the people inside the space station as well as the people here on Earth in mission control. And so they put on this communications cap before they put the spacesuit helmet on. The NASA astronauts call this the Snoopy cap. It's just a communication that has the microphones and a headset so they can hear and talk as they're performing their space mission. And one final thing I'd like to tell you, I talked about the gloves. The gloves are actually the most difficult part of a spacesuit to manufacture. They're the most customized part. Right now, I told you we make 3 different size upper torsos because people don't vary that much in terms of the size of this, but the people's hands are pretty unique. And so we currently make about 63 different size gloves. So the gloves are almost custom made for each astronaut, and if we have to make a new size glove because an astronaut comes through the program that won't fit one of the existing sizes that we already make, we have a whole form where we laser scan their hand and make a 3D mold of their hand, and then put that into a molding machine so that we mold the inner air bladder part of the suit, and then the rest of the stitching is custom done by hand on the various layers that are on the suit. So I hope that that's informative and gives you a feel for how interesting some of the jobs are that we have here in Delaware. We are always looking for new talented people, so we hire a lot of mechanical engineers and a few electrical engineers and some material science kind of people to look into the material science of various materials that we use in spacesuit manufacturing, as well as our other product lines. We also hire for our pharmaceutical containment systems, we hire chemists in that product line. So we have a whole variety of job functions that we have here at ILC Dover that we're always looking for new talented people to come join our organization. So I hope that gives you a little insight into some of the things that we do here at ILC Dover, and was happy to share these few moments with you.